Okay, so here is part 2 of chapter 9, just getting into some more specifics on multiple regression. So this is the actual analysis that's used for doing multivariate correlational analysis. And it's as I mentioned in the last part, this is a very common technique. You'll encounter it plenty in the literature. So here's an example: pregnancy risk and exposure to sexual TV content. So you can see there is a correlation here. This is not the actual data, just to illustrate that there is a positive relationship between the two. Okay. Now, of course, this does not establish causation. There are plenty of other third variables that could be at play here. It could be just that older adolescents are going to have more exposure to sexual TV content, and then they're also going to have a higher pregnancy risk. Okay. Now, you could actually, multiple regression allows you to adjust for age or control for it, okay, and examine how much of this variability in the data is explained by age specifically and how much is explained by other factors. Okay, so this is kind of what that looks like. Again, this is just the fabricated, fictitious data, but these are two possible outcomes. So if we give each participant a number indicating their age, if you were to control for it, if you were to do, this is one outcome. You can see that each of them kind of has their own cloud. Okay, so but there's no particular pattern in any of the clouds. Okay, so this is where the relationship goes away when you're controlling for age. You can see that this pattern is really just driven by larger or higher ages. That's what drives pregnancy risk up. It doesn't really have anything to do across all ages, how much you're exposed to sexual TV content. Or it's just that, if you're a higher age, then you have both of them higher, but within each age there's no relationship. Okay. Here's a different case, though. You can see within the 16-year-olds, the relationship is still there. There's still an upward trend. Within the 20-year-olds, it's the same, and 18-year-olds, it's the same. So this is where, if you were to control for age, the relationship would still exist. Okay. So you'll often see tables like this when you're looking, when you're seeing a study that did a multiple regression, where you have a dependent variable or a criterion variable, which in this case is pregnancy risk, so that's what you're trying to predict. And then you have the predictor, which is exposure to sex on TV and age. Okay. And then the beta value here is the value that you're looking at to see if it is a significant predictor. Okay, so beta is going to have a value. There's also a 95% confidence interval that gives you an idea of the precision from their data. And then the star indicates statistical significance, and that's it means it has a low p-value. Unlikely to be attributable just to chance variation. Okay, so beta sometimes is represented with a Greek letter beta. It's kind of similar to correlation in that it describes the strength and direction of a relationship, but it comes not from a correlation analysis like a Pearson correlation analysis, but regression. Okay, the difference is that regression is used for actually making predictions. We've talked before about how a scatter plot that shows that upward trend or downward trend, you can represent it with a line. Regression is going to actually give you the equation for that line. Maybe you remember y equals mx plus b from middle school and junior high. Okay, so with that you can plug in an x and it'll chug out a y, and so you can actually make some predictions with it. Okay, and oftentimes with a multiple regression, it's much more complicated than just a line. You represent it with a plane or a four-dimensional model or five or however many, so it's harder to visualize, but the same kind of idea. Okay. Now, as you add more variables, more predictor variables, you can have many of these, then the betas will change. All of them will change. Okay. So there are two predictors in this model: age and exposure to sex on TV. Okay. When they're both included in the table, then that means you're controlling for them. Or this is kind of the main one that we want to investigate: exposure to sex on TV. Does that predict pregnancy risk? But then now that we've added age, then we are also controlling for age. Okay, and you can see that age is a significant predictor as well as exposure to sex on TV when controlling for age. And then age is a significant predictor when controlling for exposure to sex on TV. Okay, so if they're in there, then the other ones are controlled for. Okay. And basically you're saying that if you hold age constant, is exposure to sex on TV still a significant predictor. Okay. You might also see B values in the literature. Those are different from beta, just to be aware. Here you can kind of tell which one is a stronger predictor, age versus exposure to sex on TV, but betas, the values aren't really going to tell you which one is stronger. Or sorry, Bs. The B isn't going to really tell you which one is stronger. Okay. But further from 0, that's a stronger relationship. Okay. So 95% confidence intervals, that gives you an idea of the precision, and also can tell you whether it's statistically significant or not. These are just some examples from your textbook of how you would actually describe this in a paper. So all of these are correct ways to describe it. So sometimes it is close to 0. Sometimes it can still be significant even though it's close to 0. Sometimes it's NS, so not significant. Yeah, so if it has a 95% CI that does contain 0, then it's not significant. So a beta of 0 means there's no predictive value to it. So this is from a study looking to see if academic success can be predicted from the frequency of having meals together as a family. And when you add this variable in to the model, if you control for parental involvement, then this becomes non-significant. So basically saying like that third variable that really explains it all. And it doesn't exactly have to do with having family meals. It's really the parental involvement that's important. Now, you can add many more predictors than just one. So from this study, they added a bunch. You can see this is a pretty exhaustive list, probably, and any plausible third variable that might explain this relationship. If you control for it, does this relationship then go away? Okay, and you can see that even with all of these controlled for, the beta is still significant. Okay. And you'll see these words in the popular press to describe multiple regression, controlled for, adjusted for, or when considering other factors such as age, gender, depression, etc. So here's just an example from a study on chocolate and BMI. Okay. Now, if you control for these third variables in regression, that does allow you to control for those ones, but it can't control for ones that you don't measure, and there may be some that you're not considering. So it's still not exactly a foolproof way to rule out all of the third variables, so you can't exactly definitively get at causation, even though you are getting closer. And here's an example of where it's pretty much, we can conclude causation here. There's almost no other explanation. Okay, smoking and cancer. Okay, so researchers, in trying to establish this, basically said, okay, let's consider any other possible explanation, and these are the things that you would observe if it truly was a causative relationship. Okay, and there is evidence for all of 5 of these things. So longer person has smoked cigarettes, the greater their chances of getting cancer. People who stop smoking have lower cancer rates than people who continue. Things like this. People who live with smokers will also have higher rates of cancer because of passive exposure. Okay, so some may argue, oh, there's a third variable there. Maybe it's because smokers are more likely to drink coffee because coffee often goes with a cigarette, and so it's the third variable of coffee consumption that actually explains link between smoking and cancer, but then it would be hard to argue for that if this is true, that people who live with smokers and don't drink coffee also have higher rates of cancer because of passive exposure. So yes, it's technically true. Causality is not absolutely 100% established here, but there's almost no other alternative explanations that account for this pattern. And you also need to consider parsimony. I mean, you could say, well, people who smoke are more likely to be visited by aliens, and these particular aliens cause you to get cancer. Yeah, it's possible. We can't completely rule that out, especially because we can't observe it. But there's much more parsimony in this explanation that it's a causal relationship. Okay. There are actual analyses that you can conduct called mediation analyses. So a mediator is kind of an in-between step. So maybe you have a certain measure of amount of deep talk that people engage in, and that is associated with subsequent well-being. Here you can't establish causality, but with a mediator, you can. It's a little bit closer, but you need the temporal precedence, where amount of deep talk leads to quality of social ties, and that leads to subsequent well-being. Okay. So this is another way that you can kind of get closer at establishing causality as well. So mediators really answer the question of why. Why is there a relationship between the amount of deep talk and the level of well-being? Well, maybe it's because those who have deeper conversations improve the quality of social ties, and then that leads to subsequent well-being. Okay, so this is something that you can plug this in as statistical software, this relationship, and there are many variations on this. Maybe you even have like two mediators, or a mediator, or another mediator that mediates this. Anyway, there's all different variations on different models that explain relationships. Okay. So there are also third variables that kind of sound like mediators, but they're different. So rather than a mediator, a third variable is kind of lurking in the shadows, and is something problematic, something that's still related to both of these, but is not a middle step. It's just something that happens to be related to the two, and may explain the relationship, but basically saying that these are just related because of chance. It's more of a spurious relationship just because they're both linked to education level. Okay. Both mediators and third variable adjustment, or controlling for third variables, they both involve multiple regression and multivariate designs. Okay, but they're different in that way. And then this is a figure from your textbook, just kind of outlining all three, how they're different. Maybe you remember moderation. Mediators and moderators, their names kind of sound the same, but they're quite different. Moderators, that is describing how a relationship is going to be different in one setting versus another, or in one population versus another. Okay, so mediation answers the question of why. Moderation answers more questions like for whom, or for in what situation are these two variables related. Okay, another important question to ask, but kind of getting more at external validity. How does this generalize, and is it actually going to be a different relationship or non-existent in a particular population? Okay, just recapping the four validities when you're investigating multivariate designs. We already talked about internal validity. Again, you can get quite close, even if you can't technically 100% establish causality. Construct validity is going to be important to interrogate with these kind of studies as well, or things like, exposure to sexual content on TV, was that properly measured? External validity, asking questions about like random samples, and then statistical validity, that's things like confidence intervals and precision. Okay, that's the end of this one.